Welcome to Managing the Future, the MIS podcast. Today we're diving deep into software procurement and development in business. Now this is really for you, whether you're maybe a student right here at the Dr. Sampak College of Business, or any college student interested in business really, or maybe you're already working and you're keen on management operations, information systems. Our goal, well, it's to break down these key MIS concepts, help you grasp these topics quickly and thoroughly. It's almost impossible to picture a business today that doesn't use some kind of software.
Oh, absolutely. From the smallest corner deli to, well, massive global companies, software is just everywhere.
Exactly.
Yeah.
But the real question isn't if you use it, it's more like what software do you get? And critically, how do you get it? Should you buy it off the shelf, develop it yourself?
Right. What does developing software even mean in a business context? What are the pros and cons?
We're going to unpack all of that today. Because let's face it, tech is important, but software is really what drives the modern world. And just so you know, all the insights we're sharing come straight from the textbook, Connect Master, Management Information Systems by Richard Tedmon and H.Schuessler Wilhelm. That's McGraw Hill 2024. And hey, to keep up with all our future deep dives, make sure you like, subscribe, follow, share, and comment. Join the conversation. Okay, so let's start with just how absolutely everywhere software is in business. I mean, you think about your phone, your laptop, even your car's navigation. Great hardware, sure.
Yeah.
But without software, they're basically just empty shells.
Right. That's a perfect way to put it. Empty shells.
Yeah.
Software doesn't just make them work. It makes businesses, well, vastly more efficient. Think about things that used to take days. Tracking inventory, analyzing sales data.
Yeah.
Now, it takes seconds. Software just streamlined everything.
So it's not just efficiency, it's more than that.
Definitely. It increases efficiency, yes, but it also helps differentiate products, track things, analyze data. It becomes a real competitive tool.
Interesting. And that ties into something we hear all the time. Data drives business. How does software play into that, especially for, say, a business student listening right now?
Well, it means that almost every big decision, launching a product, optimizing logistics, it's all informed by tons and tons of data. And trying to sift through all that manually, forget it. It's impossible.
Right.
So you need these constantly evolving software solutions to handle the sheer volume, but also to find the patterns, make sense of it all, present it so you can actually use it.
So without the software, the data is just noise.
Pretty much, just noise. Software turns it into actual intelligence you can act on.
Okay, let's unpack that a bit. Software means programming, fundamentally. But what exactly is programming? And, who's it really for? Is it a good career path for some of our listeners?
Okay, so programming at its core is basically translating a task into a very precise sequence of commands. Commands a computer or some digital device can understand and execute. It's the foundation for all software. And career-wise, the demand is huge, and not just in tech companies. It's growing in almost every single field. So if you're someone who enjoys solving problems, who's creative, likes building things...
Someone logical, maybe?
Yes, logical, definitely. Someone who gets the digital world, can work independently, but also, crucially, as part of a team. If that sounds like you, yeah, programming could be a fantastic path.
Okay, that makes sense. So for students thinking practically, what's the job outlook? And, what kind of salaries are we talking about?
The outlook is really, really strong, and the salaries definitely reflect that demand. For instance, software developers, software engineers, they're typically looking at, say, $70,000 up to maybe $110,000 a year.
Wow, okay.
Web developers, maybe a bit less, like $60,000 to $90,000. Data analysts, data scientists, the people making sense of that business data we talked about, they can start really high, sometimes $120,000 or even more.
That's significant.
Yeah. Database administrators, maybe around $100,000. IT systems analysts, bridging business and IT, around $90,000. Mobile app developers, often similar to software engineers, $70K to $110. And IT security specialists, critical role, also around $120,000.
Those are definitely compelling numbers, really highlights how vital these roles are. And I guess for you listening, even if programming isn't your direct path, understanding this stuff... It's becoming essential for any business leader, wouldn't you say?
Absolutely. You need to understand the language and the possibilities, even if you're not writing the code yourself.
Okay, so moving on. We hear terms like app and program. Are they the same thing? What's the difference?
That's a good question. They get used interchangeably sometimes. App is just short for application software. Usually we mean software for mobile devices like your phone or tablet. They're designed to be really user-friendly, intuitive interfaces.
Right, easy to use.
Exactly. The key thing is, all apps are programs, but not all programs are apps. Program is the bigger umbrella term. It's any set of instructions for a computer. So Microsoft Word, that's program.
But not really an app.
Generally, no.
Right.
But say the Uber app on your phone, that's both an app and a program. Program is just more inclusive.
Got it. That clears it up. So thinking about actual businesses,
Yeah.
what are the big must-know software solutions out there today? The ones really shaping how work gets done.
Okay, well, the giant is still probably Microsoft Office. You know, Word, Excel, PowerPoint, Outlook, they're just staples for everyday office work. Still hugely popular almost everywhere.
How to avoid them?
Very hard. Then there's QuickBooks from Intuit. That software has really simplified accounting and bookkeeping for tons of small and medium businesses. It makes managing finances much less daunting for people without, an accounting degree.
Yeah, empower small business owners.
Exactly. And the third big one I'd mention is Salesforce. It's transformed CRM, customer relationship management. It automates things like sales tracking, managing customer databases, service, marketing analytics. It's huge for managing customer interactions effectively, especially as a business grows.
Like keeping track of every call, every email.
Precisely. For a growing company, something like Salesforce becomes almost essential.
Okay, so a business knows it needs software, maybe one of those or something more specific. Then comes the big decision. How do they actually get it? Buy, customize, or build?
Yeah, that's a major strategic choice. And it really depends on the business's specific needs, priorities, and resources.
What goes into the buy decision? Buying packaged software.
Buying packaged or off-the-shelf software has a lot going for it, especially for standard tasks. It's usually pretty intuitive, often has tutorials. Lots of employees might already know how to use it.
Less training needed then.
Right. Lower training costs.
Right.
It's generally reliable, usually cheaper upfront than building your own, and it often comes with solid security features built in.
So good for things like standard accounting or HR.
Exactly. When the software isn't your core competitive advantage, buying often makes the most sense.
But what if it doesn't quite fit? What about customizing?
Customizing packaged software is that middle ground. Maybe the off-the-shelf version is 80% right. Customizing lets you tweak it. You can reduce redundant steps in your workflow, adapt it if government regulations change, or maybe respond to specific customer expectations.
So you get the best of both worlds, sort of.
Kind of. You leverage the stability of an existing product, but tailor it more closely to your unique needs.
And the third option, building it yourself, in-house. When does that make sense?
Developing your own software, that's a big commitment. It makes sense primarily when the software is your competitive edge. Or if your business needs are just so unique that nothing off the shelf comes close. Maybe your existing IT setup forces your hand too.
But it's complex.
Very. It needs serious technical expertise, not just to build it, but to maintain it for its entire life. And you take on all the security challenges, the costs. It's a major undertaking.
Okay. Beyond those three, there's the whole cloud thing. How does that fit in? Adopting cloud-based solutions.
Right. The cloud is huge now. The big advantages are accessibility. Use it from anywhere, basically. Usually better data security and backups, too, which protects against data loss.
And it scales easily.
Exactly. Scalability is key. It grows or shrinks with your needs. But there are trade-offs.
Like what?
Well, you give up some control since a third party hosts it. And while security is often strong, there's always, some risk of a data breach. It's not zero.
And we hear terms like SaaS, IaaS. What are those quickly?
Sure. SaaS is software as a service. Think of it like renting ready-made software, Gmail, Salesforce, Office 365. You just use it.
Okay.
IaaS is infrastructure as a service. That's like renting the basic computing building blocks, servers, storage, networking from someone like Amazon Web Services or Microsoft Azure. You build on top of that.
More control there.
More control, more management responsibility. And PaaS is platform as a service. That gives developers a platform, operating systems, databases, development tools to build and run their own apps without managing the underlying infrastructure. It's somewhere in between SaaS and IaaS.
Got it. Okay, so if a company does decide to build or significantly customize, how does that software actually get created? We hear about PDLC and SDLC. What are those?
Right, those are the main frameworks. Think of the product development lifecycle, PDLC, as the big picture, the overall journey. It goes from the initial idea for a software product all the way through release and then continuous improvement. It sets the strategic direction, what product are we building and why.
The whole life cycle.
The whole life cycle. It usually has phases like planning, conceptualization, design, development, and delivery maintenance.
And the SDLC.
The software development life cycle, SDLC fits within that. It's the detailed plan for how to actually build the software, the tactical how. It outlines the specific steps the development team follows: planning and requirements, design, coding, testing, deployment, and then ongoing maintenance.
So PDLC is the what, and SDLC is the how.
That's a great way to think about it, yeah. PDLC is the overall product strategy. SDLC is the detailed build process. They often work together.
Okay. And within that SDLC how, there are different ways to approach it, right? Different models.
Yes. Several different methodologies or models. 3 prominent ones you should know are Agile, Waterfall, and Spiral.
Agile seems really popular now. What's that about?
Agile is very collaborative and iterative. The whole team, developers, stakeholders, shares responsibility. It focuses on flexibility, releasing small working pieces of software frequently, and adapting to changes quickly. Great for fast-moving projects where requirements might evolve.
Okay. And Waterfall sounds different.
Very different. Waterfall is sequential, very structured. Like its name suggests, each phase flows down to the next, and you can't go back easily. You finish planning, then design, then build, then test. Each step needs sign-off. It's better for large, complex projects where the requirements are crystal clear upfront and unlikely to change. Think building a bridge.
Right. Very rigid.
Pretty rigid, yeah. And Spiral is kind of a hybrid. It mixes the structure of Waterfall with the iterative cycles and risk focus of Agile. It's good for complex projects where you expect changes or need to manage risks carefully, allowing for review and adjustments at multiple points in the cycle.
This brings up a huge point. Security. And keeping the software working long-term, these aren't just tacked on at the end, are they?
Oh, absolutely not. Or at least they shouldn't be. SDLC security has to be baked in from the very start. It needs to be part of every single phase of the SDLC, from planning through maintenance. Finding and fixing a security issue early is way, way cheaper and safer than waiting until the end.
Makes sense. And maintenance. Software isn't one and done.
Never. Ongoing maintenance is crucial. There are a few types. Corrective is fixing bugs and errors that pop up. Preventative is about tackling small issues before they become big problems. Think tuning up your car.
Proactive.
Exactly. Perfective maintenance is implementing user suggestions, adding small enhancements based on feedback, making it better over time. And adaptive maintenance is needed when the world changes around the software, new regulations, maybe the operating system gets updated, things like that. The software needs to adapt.
Okay, so after all that careful planning and building, testing must be critical. How do businesses make sure it actually works?
Testing is absolutely vital. You need a dedicated test environment. And honestly, creating good test data is often the hardest part. It needs to simulate real-world use, but without exposing sensitive, private information. That's a tricky balance.
What do they test for?
You need a checklist. Does the hardware work with it? Is all the other needed software compatible? Is the data handled correctly? Who fixes things if they break during testing? Then, the actual testing procedures. There's functional testing. Does it do what the requirements say it should do?
Does it work?
Basically, yes. Non-functional testing looks at things like performance. How fast is it? How reliable is it under load? Maintenance testing happens after changes are made to a live system to make sure the changes didn't break anything else.
Regression testing, sometimes called.
Exactly. Regression testing is a key part of that. And then there's black box versus white box testing. Black box is testing from the user's view. You interact with the software without knowing the internal code. Does it behave correctly?
Like a user would experience it.
Precisely. White box testing is the opposite. Testers look inside at the actual code structure to make sure it's sound, secure, and efficient.
Okay, thorough testing is done. Now, how does the company actually roll out this new software? Launch day strategies.
Right, implementation. How do you introduce it? There are several common methods. The Big Bang method is just switch off the old, switch on the new, all at once.
Risky.
Can be very risky if things go wrong, but it's fast. Then you have emergent change. This is more gradual, releasing small changes or features frequently. It lets you experiment, get feedback, adjust as you go. Very flexible.
Like agile development almost.
Very much in that spirit, yes. A phased release breaks the project into chunks. Maybe you release the HR module first, then finance, then sales. It limits the impact if one piece has problems and lets users learn gradually.
Makes sense.
A pilot release is where you roll it out to a small group first. Maybe one department gets the new scheduling system before everyone else. Good for testing the waters with a brand new system.
Get feedback from a smaller group.
Exactly. And finally, a parallel run. Here you run both the old and the new system side by side for a while. Users can compare, and if the new system has glitches, they can still use the old one as a backup, often used for critical things like financial systems or HR forms.
Provides a safety net?
Definitely a safety net. Gives people confidence, too.
Wow, okay. We've really covered a lot there, from figuring out what software you need to the buy versus build decision, how it gets developed, using things like SDLC, testing, and finally how it gets implemented. Understanding all of these pieces, from the strategy down to the tactics like implementation methods, it seems absolutely crucial for anyone going into business today.
Couldn't agree more. It touches every part of a modern organization.
Well, thank you for joining us for this really insightful deep dive. Now, a question for you listening. As you think about your own future career, which of those software implementation methods, big bang, emergent change, phased, pilot, or parallel run, which one do you think holds the most promise for success in today's really fast-changing business world? And why? Let us know your thoughts in the comments. And please don't forget to like, subscribe, follow, and share Managing the Future, the MIS podcast. Keep learning and stay ahead.